In this video, we're going to go through an example from the book where we explore the empirical rule and the two standard deviation rule in order to identify statistics that are unusual versus those that are usual and expected. So in this problem, we suppose that the average, the mean GPA for all students at a certain college is 2.74. Note that this is telling us that the population mean is 2.74. It is mu equals 2.74. I know that because they said it is the GPA for all students. That's the entire population of students. So then it says we collect a sample of 85 students. That's sample size n equals 85 at the school. We record our sample's average mean GPA. And the distribution is given below, a distribution of sample statistics that was generated with a computer. And it shows us a set of simulated sample statistics, simulated X bars we would expect to see if we repeatedly sampled groups of 85 students from this population. It tells us in the left upper hand corner of the picture that the mean of this distribution is 2.737, and the standard deviation of this distribution, also called the standard error, is 0.019. Now, do notice that the mean is 2.737 in the simulated distribution, even though we would expect it to be 2.74. This happens when you do simulations. They're not going to come out exactly according to our theoretical mathematical ideals. It's really close to 2.74, but it came out to 2.737 when they did the simulation of sample statistics. So I then have a series of questions that ask me to answer some questions related to empirical rule and the two standard deviation rule. Before I dive into those questions, I first label very clearly for myself a normal distribution that highlights where those plus or minus 1 and plus or minus 2 standard deviation vertical lines would fall. And I also label for myself like the 68% and 95% from the empirical rule. Once I have that all labeled, I should easily be able to answer the questions based on my labeled drawing. Okay, so here is my labeled drawing. Let's walk through how I got that. The center of the distribution of sample statistics is 2.737. That came, remember, from the given mean of this distribution, 2.737. At the top here, I'm going to label for myself that these are how many standard deviations away from the mean. Each vertical line indicates how many standard deviations away from the mean. And the mean, of course, is 0 standard deviations away from the mean. The first line to the right is 1 standard deviation above the mean, then it's 2 standard deviations above the mean. Going the other direction, we have 1 standard deviation below and 2 standard deviations below. The given standard deviation, the given standard error is 0.019. So the distance between each of these vertical lines is 0.019 units of GPA. So to find the values here, we start with the 2.737 in the middle, and then we add plus 0.019 to get to the next value, which is 2.756. And then we add another 0.019 to get to the next value. Similarly, going backwards, we start at the middle, 2.737, we subtract 0.019 to get to 1 standard deviation below the mean, and then subtract 0.019 again to get to that second one below the mean. These values along the horizontal are X bar values For example, if we had an X bar of 2.699, it means they went out and collected a sample of 85 students from the population, and when they averaged up the GPAs of those 85 students, the average from that group was 2.699. Okay, lastly, I'm just going to note to myself, the empirical rule tells us that 68% of the data will fall within one standard deviation of the mean, and it tells us that 95% of the data will fall within two standard deviations of the mean. The two standard deviation rule tells us values beyond two standard deviations are considered unusual. Up here is the unusually high statistics, and down here is the unusually low statistics. Now that we have our label drawing, let's answer the questions. The first question asks us to use the empirical rule to finish the sentence. Blank percent of samples of 85 students had statistics where the average GPA was less than 2.718. Less than 2.718. So that would be statistics that fall here in this circled blue region, below 2.718. So notice that 68% of... Aiden, be quiet! Notice that 68% of the data falls within one standard deviation. That means that 34% of the data falls outside of that range. Notice that 68% of the data falls within one standard deviation of the mean. That means outside of that range, in these circled regions on the left and right, would be 32% of the remaining data, right? 100% of the data is under the curve. There's 68% between that little range. That leaves 32% on the outer tails. So if you split that in half, that means that 16% of it would be down here, and the other 16% would be up here. 16% and 16% makes up the 32%. So it's now asking us to find the percent of samples that were less than 2.718. So 2.718 is right here at this vertical line. They're asking for this group. What percent of the statistics are in that little range? Well, it's 16%. 16% of the data is in that little range of the normal curve. Next, we're asked to use the two standard deviation rule to complete the sentence. It would be unusual to have a sample of 85 students where those students had an average GPA that is more than blank. So I'm going to again just sketch this out real quick. All right, so I just made a little sketch that just has the values of interest on it. So the value that is two standard deviations above the mean is 2.775. The value that's two standard deviations below is 2.699. These are the cutoffs for statistics that are unusually high and unusually low versus those that are expected and usual. This word unusual, according to our two standard deviation rule, it's two standard deviations. That's the cutoff for that. So which ones are the statistics that are unusually high? Those that are more than 2.775. These up here. It would be unusual to get a group of 85 students that had a GPA more than 2.775. Those statistics are unusually high. So the last two questions are really similar and use that same sketch that we just drew there. It says it would be unusual to have It says it would be unusual to have a sample of 85 students where those students have an average GPA that is less than how much? Well, less than 2.699 would be unusual. And lastly, when collecting a sample of 85 students, the usual expected average GPAs are those that are between 2.699 and 2.775. So these in here, the 95% that are between two standard deviations from the mean, these are the usual expected sort of statistics to get if we went out and talked to 85 students on this campus.